The inverse function of the exponential function is called the natural logarithm. So because they're inverse functions, the natural logarithm, written as ln of the exponential function of x, is equal to x. You may have learned about logarithms already. So another way of writing the natural logarithm of x is to write it as a log, L-O-G, base e of x. So because the exponential function satisfies some arithmetic operations, the logarithm satisfies the inverse operations. So for example, the log of x times y is equal to the log of x plus the log of y. The log of x divided by y is equal to the log of x minus the log of y. And the log of x raised to the r power is equal to r times the log of x. If we look at values of the exponential function that we know and reverse x and y, we get values of the natural logarithm. So for example, we know that e to the 0 power equals 1. So that will imply that the log of 1 is equal to 0. And we know that e to the first power is equal to the number e. So that will imply that the log of e is equal to the exponent, which is 1. Together, the exponential function and the natural logarithm allows us to define x raised to any real power. So the power law, x to the p. So now we're not only talking about p being an integer, but p can be any real number. We can write that as the exponential function of the natural logarithm of x to the p. And because, let's say, we don't know how to define x to the p, but we know how to define the exponential function in the natural logarithm, we can write that as the exponential function of p times the logarithm of x. So this gives us a very nice definition of a general power law. Okay, so we've got the exponential function and we've got the natural logarithm. Let's look at their graphs. Here is the graph. This rapidly growing function is the exponential function. As x goes to minus infinity, it goes down to 0. If we take the exponential function and reflect it about the line y equals x, we get the natural logarithm function. Because it goes to 0 as x goes to minus infinity, we have the x and the y values reversed so that as x goes to minus infinity, y goes to minus infinity. So this function then, as x goes to 0, y goes to minus infinity. So the logarithm comes up from the y-axis and then is a very slowly growing function because it's the opposite of the exponential function, which is a rapidly growing function. This is just a reflection about y equals x. So let me summarize. The inverse function to the exponential function is the natural logarithm. That's the log base e of x. It satisfies some good algebra that you need to remember. The log of x times y is log x plus log y. The log of x divided by y is log x minus log y. And the log of x to the r is r times log x. We have log 1 equals 0 and log e equals 1. Now, using the log and the exponential function together, we can now define a number, any x raised to any power, p. P now can be any real number. And we can define it through the fact that the exponential function and the logarithm are inverse functions, and we can pull the p off of the exponent. When we take the log of xp, becomes p times log to the x. We know how to multiply log x by a number of p. Finally, I showed you the graph of the two functions. The exponential function goes to 0 as x goes to minus infinity and is rapidly growing as x goes to positive numbers, while the log is the inverse of that. As x goes to 0, it goes to minus infinity, and then it's slowly growing when x goes to positive real numbers. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.